Okay, hi everyone. I hope this video finds you well. So today we are going to talk about the Boolean logic, and we are going to combine Boolean values with and or. The logical and the logical or. So in today's agenda, we have combining Boolean values with logical ands and or, solving compound Boolean expressions, and eventually you will be able to do the quiz on the compound Boolean expressions on Canvas. So the Boolean logic, what is it? And why it is so important to us? So as you know, the Boolean logic is vital part of programming, and the Boolean logic only has two values, the true and false. So there are no maybes in the Boolean logic. So it's either true or false. And we usually use it to decide the flow of a program, whether to perform an action or to stop, right? So logical and logical or. So the logical and operator, which we use the two ampersands, and the logical or operator we use for it the two pipes or the two bars, allow you to connect multiple Boolean expressions to create a compound expression. So the logical not, however, is represented by the exclamation point. So that reverses the root of a Boolean expression. If it's true, it makes it false. If it's false, makes it true. So in the logical and, both sub-expressions must be true for the compound expression totally to be true. In the logical or, one, at least one, or it could be both, must be true for the compound expression to be true. So you can rephrase that to say at least one of them, one of the sub-expressions must be true for the total compound to be true. For the not, as we said, it negates or reverses the value to its opposite one. So here's sub-expression that says is x greater than y. And here's another one. Is a less than b? Now, if you want both of them to be true for something to happen, then you need to use the and, like this. If you need either of them to be true for something to happen, then you use the or. And if you want the not of something, the negation of something, then you use the exclamation point before that expression. So let's start with the Boolean or the logical or, which again is represented by the double pipes in C++, and you can find that above the enter on your keyboard. So it's above the enter in your keyboard. You use shift and the backslash button on or key on your keyboard. So there are times when I need to know if one of two things is true, and usually to make a decision. So for example, in the morning, I need to decide if I should bring umbrella with me when I go out. So I would say I would take umbrella. So here is my decision to take umbrella or not. So I would take umbrella if it is raining, or if the weather forecast report calls for rain, right? So if either of them happened to be true, then I will take umbrella. So my decision is based on either this one or this one. So I only need one of these two cases to be true to decide to take umbrella or not with me. So here's the Boolean or. The forecast says it's raining, or I look outside and see it's raining, then I take an umbrella, right? So here is the or truth table. So if it's true, either of them, as you can see, we just need one to get to the true. Even if this one is false, this one is false, we don't care. So if both are true, definitely it's true. The total result, to take umbrella, right? If either of them is true, then it's definitely true. If both are false, then the total result is false. So the Boolean OR is like if you have two gates and left gate is closed and right gate is closed. So definitely you have sad sheep because they don't get to grass, right? There is no access to the tasty grass if both are closed. However, if one of them is open, now either if it's this one or this one, then you have happy sheep because they have access to the tasty grass. If both are open, okay, that's even cooler because then they have more than one gate to enter to the grass, right? Which basically makes it true. So if you have true for the left gate and the right gate openings, then you have true. If you have either of them open, which makes it like we are represented by true, then you can say they can get to the grass. If they're both closed, which we represent by both false, then the total result is false and you have sad sheep. Okay, the Boolean AND, which is represented by the double ampersands, there are times when I need to know if two things are both true, not just one of them, but both. For example, my friend likes to go with me for coffee if I have, or if I leave before 9 a.m. and it is a sunny morning. So it should be a sunny morning and I do have to leave before 9 a.m. So if both of these conditions are true, then I should stop by his office and get him, right? But how to represent two things in just one single value? By using the AND. You use the AND in here, right? You said, I leave before 9 a.m. and it is a sunny morning. Now, if both are true, accumulatively, then I would say the total result is true, which means go get him and go have a coffee with him. So, before 9 a.m. and sunny outside, then coffee with your friend. So, here is the AND truth table. If only you have both were true, you can pick up your friend to get a coffee, which makes it like we're represented by true. So you need all of the conditions, all of the conditions to be true to get to the true. If any of them were false, then it's false. Right? So you have every sub-expression to be true to get to the total true. If any sub-expression is false, you have it as false. So it's like you have both doors, like you have two walls with doors in each one. If you have double doors, if either of them is closed, you cannot get to the treasure, right? If either one is open, still you cannot get to the treasure because, yes, this one is open, but this one is closed. In the other case, this one is closed and this one is open. Still, you can get to the treasure, right? But if you have both are open, then you can get to the treasure, right? So you have to have both of them. So combining Boolean values with logical and logical OR. So if you have true and true, the final result is true. The final result is true. Because this is like if it's sunny outside and you leave before 9 a.m., right? Both conditions were true, then the final result is true, which this means go pick up your friend. So now there is a quiz on Canvas about combining Boolean values. Go do it. Pause the video, go do it, and come back to continue this lecture. Okay, assuming you did this quiz on Canvas, moving on with the slides. So we have already practiced quantifying simple Boolean expressions, like is 6 less than 7, and that is true. Is 3 less than or equal to, that is false. So now we can combine multiple expressions with logical operators like the logical and logical OR. So here is the order of operations. You usually do the sub-expressions with the less than or equal, greater than or equal, equal or not equal. Then you do the and or the logical OR. So it's something like that. First, you need to get that to either true or false, and this one to either true or false. You have to shorten that, right, to a single value, true or false. Then you connect them with the operator ampersand, like the logical AND. So is the age less than 8? Is the height less than 57? It's like 57 inches. It's like when you're talking about a toddler. You can ask these questions, and you need both of them to be true for to decide whether the toddler can get to the booster seat or not, right? So if the ampersand had a higher precedence, for example, then you'd say, for example, let's say that was true. But then true and height? No. So this is why you should get this first, then this second, then you would be able to do this. Like this one, for example, true, the final result is true. False, true, the final result is false. False and true, that was false. False and false, that was false, right? This is how you do things in the logical and the logical OR. So, for example, here is something. If you're going to a park, if the age is less than 8, and or the age is greater than 65, the person gets a discount. If anything in between, that person does not get a discount. So how would you represent the condition where someone gets a discount? You would say if the person's age is less than 8 or the person's age is greater than 65. This is where we say or. Here is something. If the age is less than 8 and the height is less than 57 inches, then the person gets to use the booster seat. So here's an example. Is 5 less than 0? Now first we do this. Is 5 less than 0? false. Now, usually the compiler will think about it this way. If this is false and this is OR, then it must do this one to check, because you need a single true to make the whole thing true in the OR. So is 3 greater than 5? False. Then false or false, you don't get to pick, right? It's false. So false or false, this is false. Now, usually, the compiler, if it sees anything, the first one true, and you have OR, the compiler is not even bothering to get to this one. But this example is not the one we should talk about, this phenomena. So 3 less than or equals 0. This is definitely false. 6 greater than 3. This is true. Which one to pick? Because this is about picking. Or is about picking, right? You would pick the true. So, true or false? True, definitely. Okay, what about this one? 0 less than or equals 0. That is true. Then 2 greater than 3. That is false. Since you have AND, you need both of them to be true to get to the true, but you don't have both of them true. So this is definitely false. So here is that. So usually with the compilers, if you have the OR, whenever the OR encounters true, it stops and say it's true. If you have OR. For example, look at this one. So I have true in here, right? Do I have to check this one if I have OR? Usually not, because true or anything, I would pick the true. Same thing in here. If I have false and I have AND, false and anything is basically false. So you can think of it this way. The OR is the plus, the addition. So true plus false, and you would represent that by 1 and the false by 0. Any true is 1, any false is 0. 1 plus 0 is 1, right? Positive. Positive means true. 0 plus 0 is 0. 0 means false. 0 plus 1 equals 1. True, right? 1 plus 1 equals 2. 2 is greater than 0, which means true. This one, multiplication. The AND is multiplication. 1 times 1 equal 1. True. 1 times 0 equal 0. False. 0 times 1 equal 0. False. 0 times 0 equals 0. False. Right? So you think about the logical AND as the multiplication and the logical OR as the addition. Okay, as a conclusion, Boolean logic is vital to programming. Only has two values, the true and the false. Boolean expressions are evaluated into a single Boolean value, and we use the logical AND and logical OR if we have more than one sub-expression. Compound Boolean expressions are evaluated into a single Boolean value, because definitely we need just a single value to decide. So conditionals allow programs to make choices. Practice it. Do the quiz on Canvas. You have more than one quiz in this module. Do them because it's vital to your success. So next lecture, we are going to talk about the conditionals. So to prep yourself to the next lecture, answer those questions from the affordance sheet I gave you. What is the affordance of an if statement? What is the affordance of an if-else statement? So the affordance for the if statement is providing the ability to either do a block of code or skip it. What is that for the if-else statement? Either do a code of block or do another one. So choose between two blocks of code. So the if statement's like used to make a choice to choose do something or skip it. For example, if I'm approaching a red light in my car, if the light is red, I slow down, otherwise I would keep going, right? Or at least this is what we do usually in here. Even though the yellow means slow down. I see some people on the yellow, they keep going. Hopefully they won't make any extends any time, because this is a little bit dangerous. So if you see usually a red light or a yellow, slow down. If it's red, stop. If it's yellow, slow down to prepare yourself to stop. Anyway, so if is red light, slow down to a stop. If else statement used to choose between two blocks of code. Should I turn left? Should I turn right? So you'd either go left or right, right? So if turn equals left, then I would activate turn left sequence. Else, I would activate the turn right sequence. So that was just a preview of next lectures. So now make sure you do all the quizzes on Canvas. These quizzes to be found on the same module contains this lecture. So have a good one. See you in the next one.